Right, hello everyone, welcome to another stream. How are we all doing? So, Seven of the editor. So last stream we was implementing the upload buffer. Ooh. There was one thing I want to add to this. So, what was I forgetting? Add a way to upload to buffers and textures, right? Transition. Transition the upload buffer. Comment and clean the code, right? There was something I was forgetting, I remembered it. Hey Perry, hey Glorissa, how you guys doing? Good to see you. How's things? Oh my days, what was it? There was something to do with the upload buffer that I was remembering. So we have to do this transition code at the start of the frame, which I think we already did. Oh no, yeah, we did it for the other stuff. Comment and clean the code. Yeah, I think I forgot. Oh well, I will remember it. Yeah, so last stream was implementing this thing called an upload buffer. So the way you can think about it is something like this, where we have an upload buffer where we essentially write some updates into, I think I'll redraw it. So we have a buffer that we make in the Vulkan backend, and we call this super lovely function called GPU upload buffer. And you pass in the target of where you pass in the where you want this updated data to go at a certain offset and what size you're uploading. And then you get back a void pointer you can fill in. You'll get a void pointer into this buffer here. You'll write into this buffer. And then it will keep track. Oh, I can't zoom out anymore, okay. It will keep track of this res ID in this offset. And at the start of the next frame, it will copy this into the correct place, right? And that's what was implementing last stream. So we're hopefully going to finish this off today and get something working. And maybe do the opposite version where you can read something back, right? How's the lighting like? Cool. Yeah, so also there's some other news. Potentially I might have to disappear if my wife ends up going into labor, which I don't know if she is or not. Because she went and did a test today to check if she had too many, oh my days, what's the term? If she effectively has an issue with sugar. So they pumped her with tons of sugar and now she's got high blood pressure, so she might go into labor, I'm not sure. So I'm just sitting here like seeing if there's a, yeah, that's it, yeah. I'm sitting here waiting now to see if there is, she's being examined right now to see if there's any options that they could do to help her with the effects she's feeling. So yeah, we'll see what happens. So I'll be keeping an eye out on that one. Yeah, hopefully they inject her with something. I'm not sure. Right, GPU C. So I just wanted to rename this manual one to just upload manual. All right. So what's the next plan to do? So we've got a to-do list. Transition the upload buffer for the transfer at the start of the frame, then to compute shader read access after that. Okay. So in the Vulkan backend, how goes the Devin? I'm working on a machine learning project that uses Vulkan compute shaders for GPU processing. Cool. Yeah, it's going good. We've got graphics on the screen. We've got most of our GPU API sorted out, which is our high-level API. We're testing the ability to upload to resources, so we can actually test our abstractions here for a buffer and a texture. But yeah, things are going good. It's got a very simple API, which is good. So we're looking at getting, so at the start of a frame, so we got a frame start. Yeah, I'm not sure if my application runs. No, it doesn't. Okay, I can't show. So at the start of a frame, we do some transitioning of the, here it is. So this one, yeah, maybe I've got to put it in here. So we need to so this one be like transition the upload buffer and the destination buffers and textures into, well, it's not really transition, it's more like, okay. Place a pipeline barrier for the upload buffer and destination buffers and textures. Upload, okay. So I think I want to automatically add an upload buffer one. Specifically for the upload buffer itself. So this one needs no sync state. Yeah, so no sync state. I've already done it. Okay. Because the source would either be, so say it was last used in a compute shader, right? And then it was last read from VK access mode 2 shader read. Oh, come on. Give me some more than that. Shader storage read. Then destination, it's good. Cool. Yeah. Right, then the destination is going to be used in a copy and we're going to be reading from it. Right. And we're going to pass in the buffer. So GPU VK dot upload buffer. So this is the one we made. This is that VK buffer we made last stream. For a while I pretend that all my buffers were E32 until I started working with someone else who was like, no, we should really actually care about what types are in these buffers. Right. Well, it depends, right? Your buffers could be Or especially if you use binderless, you kind of want it to have a type actually, yeah. But yeah, since this is a C API, just make it a void pointer and just cast it to what you need it to be. But yeah, if you're doing programming in Vulkan the old school sort of way, typically you can make it anything you want and then bind it and sort of like change the offset of the buffer when you bind it. Not so much the case anymore. Damn it, Amazon. What have they delivered now? Bastard. So I've just got an email just saying that Amazon's delivered something. Clearly haven't. And this happened to me literally 4 hours ago. They delivered something to someone in a different estate, and that person drove over and dropped it over, which was really nice of him. What package has been delivered? And then just says parcel's been handed to a resident. So great. Amazon, like they've been fine, but like I don't know what's happened. It's so bad. I'm not sure if we're in like some end of the world crisis here, but they used to be good. And it's just not anymore. Yeah, but like people always take photos. Like you've seen, I've had like people from other services. They take photos of where it is and everything, and they upload it onto the website so you can see it. But with Amazon, they don't do that. So annoying. The shaders don't care about binding UFO2 buffers, and they just treat them as floats. Right. Yeah, it's kind of good though. Amazon lies to me all the time. Yeah. I'm only on implementing C++ Vulkan engine 2. Curious what features you're currently trying to implement. Just a staging buffer, or an upload buffer as we call it. So we can upload to the shaders. To a buffer or to a shader, or to a texture. And we also will probably implement printf today, because our custom shading language, HCC, if you go into the sample code, if you go into the triangle sample, what you'll find is HCC, the custom C compiler for shaders, has a lovely printf function. It's called hprintf. You give it a buffer, you can do all the stuff you want, and output it to that buffer across, every single pixel on the screen if you wanted, providing your buffer is big enough. And so, just to prove that it works, if I open this terminal right here and run the samples, this is all printing from the shader, and it comes back to the CPU, and we print it out to the terminal, so we can see all the values that we want. So this is super useful for debugging, so I want to hopefully get this in today as well. We'll see. Yeah. So we're doing the other way around first. Yeah, exactly. They don't even ask for the name, or they don't even read the road sign, because it's a completely different address. Crazy. As I'm going through some, first they make great user services and they stop caring about users and great. Yeah, and also they're probably not too decent to the people they hire, maybe as well. Probably. The only thing they've been reliable with is sending me my books. Yeah. Yeah, it's cool. You've started your C++ and Vulkan engine. Um, how far are you in that? Have you got like a triangle up and running? Do you have like your synchronization code in? Like, how far are you in that Vulkan and C++ engine? Um, cool. So this is going to synchronize the buffer, the upload buffer itself, but after. So this is where we're going to do all of the uploads, right? Copy all of the uploaded data from the upload buffer into the destination buffers and textures, right? And then we want to go down. I don't know why I copied that. I want to go down to here. No, I wanted to. Yeah. Place a pipeline barrier for the upload buffer and destination textures to restore. Wait a minute, is this a good thing? Okay. Now we have copied the uploaded data, and then the one up here is going to say right before we copy the uploaded data, right? Okay, so we just need to copy this thing now and get it swapped the other way around. Let's do that. So down here we're going to paste this in, and for the upload buffer we're going to add a new barrier in, and this barrier is going to essentially swap these two guys around. Oh, did I get that right? Yeah. So it used to be read from, but now it's going to be read from in a compute shader after this barrier, which would be awesome. And yeah, so I think that's one thing ticked off already, which is super good. So we can now go into the header, delete this line here. Excellent. So the next thing to do is like comment and clean the added code. So we're going to go around all the stuff we've added, clean up, make sure it's all good, put some extra assertions in, and then we also need to try and get it running and actually make sure we poke the correct resource descriptors in the descriptor set, because we haven't even done that yet. So we'll be writing that code as well. And then we have that code, we should be able to initialize a buffer, use the upload buffer to copy or initialize a texture. We'll get a logo rendering on the screen or something, right? So that's what we want to do. So the code, all the code we added was these functions here, I think. So let's have a look. Yeah, so I want to put an assertion in to ensure that let me think about that. Right, let's catch up. Right now I have a scene with a bunch of primitives I coded up. I can add and remove mesh instances to the scene with a simple materials, resource manager, tracking lifetimes, nice. Global frame, material instance, descriptor sets, nice. Got MGUI hooked up this morning. Cool. So it seems like you've actually got some stuff rendering using it, which is quite a good achievement. Do you have like a frame graph or a render graph yet? Or are you sort of like doing very temporary synchronization code and you're solving that problem later? They say GPU program doesn't count as an exercise, but I've been getting a buffer every day. Okay. Okay. Right. So do I want to put an assertion in for the size to make sure the size is actually aligned to something sensible? Like, I don't think it matters. Shouldn't matter. Like, our minimum limit is 4. I don't think it'll matter though. So what we're doing here is just saying if it's not started, we're going to say this function must be called after frame start. Excellent. So we get the source offset. Does this thing get cleared? So does the cursor get cleared every frame? I don't see it getting cleared. Okay, so in frame start, this could have been a big problem. So in frame start, we want to make sure that we say GPU. Set the cursor back to 0, please. No. After we've called the backend frame start, clear it out. We could do it at the end, it doesn't really matter. Yeah, okay. So I'm glad we found that problem. So we're going to get the mapped memory range. Get the pointer, get the resource, make sure it's in bounds, yep. Get the entry, keep note of that for later, up the cursor. Yeah, it seems pretty good. I don't think it really needs too many comments. It's quite understandable. Yep. Okay. So I think we've already dialed the comments around. Should we just do a git diff? Take a look around. So we've added this upload buffer stuff. And yeah, I think that's all pretty good. So let's try and get this thing running. See what happens. Because I remember it kind of crashed, right? So we've got to see what this bug is here. So in buffer create information, the sharing mode is sharing mode concurrent. Okay, so we've got the stack trace here because we've got stack traces built in, which is really nice. So back in initializing in Vulkan C494, oh shoot. What? Oh, we're going to say exclusive. Wrong one. Let's fix all of those. Okay. So allocate memory has failed. Got an invalid index. So this one is in 529. Interesting. So I don't know if it can find an actual thing. So we're going to put a breakpoint in here. Call breakpoint. And so open that up in the debugger, follow it through how it does the selection, just really read what's going on. We're just looking for host visible, you know? No running graph yet. Right now, pretty hard-coded sync code. Makes sense. Don't even have enough render passes yet. Plan is to go hardcore once it all becomes too painful. Try code up render graph. Nice. Yeah, you can manually place sync code. We're going to probably automate our synchronization code. We've got a manual version right now. We're going to try and maybe automate it, but it won't be optimized as well optimized as if you do a work graph. Because if you have a work graph, you can like reorder stuff, right? Whereas if you don't have a work graph, you have to manually reorder the code to be efficient. Right, so open up GF. And then let's hop into this function call. So we should have some bits, right? Got some bits. It's not going to be helpful. So the required flags we had is host visible, right? So pvk required flags. Come on. What's this thing doing? 2. Right, so we're looking out for the 2-bit set, right? So that one was probably device local. That's another. Well, what is that? Let's have a look. Yeah, device local. Right, so looking for this one, host visible. We're not advancing the memory type index, is it? When we hit continue. Damn it. Alright, don't mind me. The first one just worked by luck because it grabbed the first one. So we iterate over all the bits. Wait, where's the least set bit? No, it is doing it, isn't it? Huh. Right, but it's not doing that every single time it iterates. So just saying get the least set bit in that bit set, and then that, yeah. Okay. Let's try that, see if it works. Let's remove the breakpoint. Oh yeah. Okay, so this is what we have working right now. We just have 2 compute shaders running. One does the background and the other one does the foreground, and it uses a sign distance field to render this triangle. It's not using any triangle pixel shader, it's just a compute shader. Hey there, Razzle. How you doing? Good to see you. How's things going? Right. So what's the next thing we need to do? So the next thing we need to support then is actually poking in the descriptors into the descriptor set so we can actually use resources in shaders, right? We've not done that yet. We've got it. We've got the code ready, it's just we're not written it yet. So let's look for update descriptor sets. So what we need to do is go over all the resources, and so long as two seconds, just gonna phone call. I'll be back. Hello everyone, welcome. Sorry about that. Just got a call from my wife's mum, and yeah, because my wife's currently in hospital, but she's good. She's good now. They're sorting out her blood pressure. So I've just heard good news. Everything is fine. But yeah, hey there, Ansel. Doing good. Got some holidays right now. Excellent. You got any plans? Yeah, it was. I wasn't so anxious really because I know she's a very healthy lady, and yeah, and worst case, I'll just have to like deliver the baby now. But they've managed to get her blood pressure down now, so that's good. The only problem is she went to have a test to see whether she had where she had if she was not intolerant to sugar, right? So they gave her a big load of sugar today, and obviously that's not too good on the body. So it made her a bit ill. So yeah. Well, maybe interesting. Well, maybe want to go and do compute. Just because like Vulkan's like crazy overcomplicated, and there's a simpler API within Vulkan. I want to explore. Could we do something compute only? There's been other inspirations on that as well, but that's generally the base idea. Oh, that's nice. My sister had a premature baby and she's fine. Yeah, yeah. The babies are typically good to come out. You know, like they can come out like quite early. All things considering, it's all good. UE5 nanite. Well, that's an example of using compute, right? Is the nanite thing, but we're not doing triangles. Right, so we need to upload these descriptor sets. So the most optimized way to write this would be I don't know actually. It's difficult. It's really difficult because you can't have a null descriptor. Oh, we can. We'll make it. Yes. Solution. Right. Here's the problem. In Vulkan, you cannot have a null descriptor, right? It's really annoying and really dumb. There is an extension for it. Not got a lot of support on devices. So what is the problem with this upload descriptor sets API? So what we have, let's check out Milton here, right? Here we go. So what we have is this. What we have is a descriptor set, and the way you can think about it is it's just an array of descriptors. Remember we looked into what descriptors were in the past. They're just like a data pointer and some extra metadata about the buffer or texture. But they differ between each platform. So essentially a descriptor set maybe has an array of descriptors for buffers at the top, and then it has another array for textures, right, of descriptors. And these are the things that this is the memory that the shader will use when you say, hey, I want to load for a buffer or load from a texture. So what we need to do is update these descriptors, and this is what this VK write descriptor set thing does, right? So the thing that we need to do is, so when you call write descriptor set, it's really good at updating arrays of things. So if you see in the descriptor set, yeah, descriptor type. So this descriptor type is basically, hey, it's a buffer or is it a texture, right? Which is a bit painful because you're only allowed to upload arrays of things. So you can upload multiple that are next to each other. But because we're using this thing called, because we're using, like, we have massive arrays, and we only have to bind the descriptor set once, right? Because essentially, there might be holes in this, like, what's the best way of saying it? We're using, in our high level API, we actually have an array, or a pool, which will be in the future. We have an array effectively of resources. Now, a resource just means a buffer or a texture, but that's the way we've done it, is they just share the same array. So we use the same index to go into these different, types of descriptors, and essentially this index here will just be an empty slot in this texture one, right? It'll just be empty. So if this API is really good at uploading arrays of things, but some of them are going to be empty because it could be a texture when it's in the buffer descriptor set, for instance, how can we update these without doing something crazy? So the most simplest way to fix this problem is we need to create a buffer and a texture as a and I'm not sure if it needs memory or not. Maybe we can get away with it not. Maybe we'll need memory. But we just need to upload a buffer and a texture, which is like maybe the most smallest size. And we can fill it we can make that our null buffer or null texture. So we should be able to roll with that, I reckon. So I've had to do this in the past, actually. It's quite a good solution. So let's solve the problem. So source GPU, GP backend, internal. I want to add a null buffer and a null image. Yeah. So we're just gonna we're just gonna make these very quickly, and then these will be the things that we fill in the empty slots with. So it should be super good. Just fix up the music. So let's go to where this upload buffer is actually initialized. Here we go. So we're going to take this. We don't need to map the memory. So create the null buffer. So create the buffer. Size is just going to be 1. How's it going to be used? Well, it's going to be used inside it's to be a storage buffer, right? Because it's going to be uploaded as a descriptor. And then we want to make sure that the null buffer. We don't need to find the memory type. So this is going to get the requirements, the size and alignment information. This is going to allocate the memory. Upload null buffer. No map memory. Yep. Sweet. So we now need to do the same thing, but for a texture, for an image. Got any suggestions making your own color scheme? I've not really got any suggestions. Like, for me, the reason why it was so simple is because it's basically 2 colors, right? I wanted more of like a red theme, and I just like having 2 colors. So I basically just like specifically solved it for my setup, because I've got the Clang LSP and tree sitter stuff installed, isn't it? So it can leverage those things. I can color the elements I want. So all I've done is just done that effectively. But yeah, I don't really have too many ideas. Just kept tweaking it until I got something that felt right and that I liked. I guess if you're doing something any more complicated, you might have to know theory about the colors you're picking. Maybe, I don't know. Like I think the best advice I can give is just keep it simple. Yeah, so now I want to do the image one. Image create info. So this is the texture initialize function that we have. We're going to take all of this. But we don't need a view, right? Create the null texture, null image. No worries. What type do we need? It generally doesn't matter what type we need, but we'll just do the image 2D, right? Then the format doesn't matter. So we're just going to do format R8 R8 G8 B8 R8, right? Just a standard one. Extent 111. That's all we need. MIP levels 1. Array 1, optimal tiling, sampled and storage, because we're going to be using it. For. What we're going to be using in. Yeah, because we're going to be using it in the sampled and storage descriptor set types. That's why. Then this would be a GPU. Null image. Then the null image device memory. Yeah. Now we just need to bind that memory. And there we go. Right, so now our descriptors, we can now fill in our upload descriptor stuff. So update descriptor sets. Oh. Right, I just got a text from my wife, so I just quickly want to give her a message back. I think you... I don't know. Right, there we go. Oh, let's just get the chat back up. I just closed up my phone. 2 seconds. Okay, we're back. Right, found this alternal.sexy. Yeah, it's a good site. Which version of C? We're using C11 because C99 was a real good release. C11 it has some good bits. Brings in a few modern things, which are not which were not bad. C23, it's got some nice things in C23, but some things they've brought in where it's like you're kind of beginning to ruin the language, and you could see like they're bringing in like they're solving problems in a very weird way, but it's not. But not necessarily like completely ruining it. But you can see how like if they keep going with these sorts of updates, it could be bad. But yeah, it has some really nice features in it. C23 does, but yeah, I just hope they don't keep adding features like they have been adding. Yeah, this one's a really good one. You can have a bit of a tweak. Yeah. The only problem I would say with this is that you don't get to pinpoint the exact things you would have as you would in your local Vim, because you might have extensions and things. But yeah, you can like browse color schemes that are already. Yeah, browse some color schemes. Wait, isn't there meant to be more? Yeah, here you go. Yeah, you can browse these. You can take some ideas that you like and then like make your own from that. Yeah, it's a good idea. That's cool. Yeah, it's a nice website. Oh, I'm just close that one. Cool. So, how are we going to solve this problem? Like every other problem in programming, arrays. So what we need to do is have arrays of this VK descript set thing. It's a big chunky bugger. See, we could make it better with the template stuff, right? Yeah. No. No. This is the Let me do some research. So they have this write descriptor set thing, but the structures are quite big. But I think there's a way to make it better. So there's a template. Update with template. It came in Vulkan 1.1 as official, but initially was an extension. So what you can do is you can describe offset and stride. Okay. So so effectively you create a template, and then after you've created the template, you say update descriptor set with template. And then you pass in a void pointer with the template thing. Yeah, I think this is the way. Yeah, this is the way. Because what we can do is we can, instead of making these big image... What are these things even called? Yeah, descriptor image view infos. So these get quite big. Wait a minute. Wait, this might be the structure you're using. 2 seconds. Maybe it's not solving anything. Let's just quickly do a research. Set layout. Entry. Right, so an entry is like... descriptor count. Right, Right, let's see that VK descriptor set. Yeah, so I think the problem is it's still going to be the same thing. So I think this will make it so instead of doing 4 calls to update descriptor sets, we'll only be doing 1, and it'll be using the template. So I think it's still good to use if that's the case. But I was hoping if we can make the structure smaller. Update descriptor set. With template. So the problem is, what is this void pointer, right? What's the shape of the data? Yeah, so it's these image infos or buffer infos, right? So it is what I thought in the end, I guess. So I think it's best if we use this, because then it means we can, it's more efficient. We can allocate a buffer, poke in all the updates, and then it should be then it's one call to update descriptor with template. So I think we'll use this. So let's bring these functions in. Create descriptor set, so stick it here. Oh, maybe we should include this in HCC. Maybe you can create a template for you. Because we do have an interop layer which creates the descriptor sets already. Maybe. What ID do I use? Vim? Or technically NeoVim. What's the problem? We're just trying to update some descriptor sets. I'm just trying to find the most efficient way. That's what we're working on right now. So we could create an update template. So if people use the interop layer with HCC, they've got the, yeah, maybe quite a lot of stuff can go in there, I'm not sure. Nah, I think I'll leave it outside for now. Right. Maybe we can move it in if it makes sense. Update descriptors with template. Rightio, here we go. So now we've got these function pointers, now we can start to do things. So we need one of these guys. So right after when we initialize the interop, we want to create a create info. Whoa, hey there, Provod. Thank you so much for the raid. How did the stream go? Welcome, viewers. How you guys doing? So we're working on a game from scratch. Just currently writing the engine code specific for this game. So we're just doing the GPU abstraction layer right now. So we currently have this window, which is two compute shaders. One's the background, one's the foreground, and the foreground one cuts out the rest of the pixels and makes a triangle. But yeah, if you have any questions around the project, feel free to ask and we'll dive in. So we're currently making an upload buffer where we can upload data from the CPU to GPU resources, and we are currently just updating the descriptor sets so we can actually use buffers and textures in the shaders, other than the hard-coded one we have here, which is the surface resource. But yeah, how was the stream, Provod? And how is the project going? VK structure type. So this is the descriptor update. Oh my days. Descriptor update with template create information. Null pointer for the p next and 0 for the flags. How many entries we're going to have? Okay, so we're going to have 4 entries. I reckon we can say we're going to have... wait, is there the interrupt layer stuff? Yeah, interrupt binding count. 1 for each binding. And then the entries, let's get that. Type vk descriptor update template type descriptor set layout gpu vk interrupt dot descriptor set layout bind point compute gpu vk dot. It's interesting it's got a bind point. Pipeline layout, interrupt, pipeline layout. And the descriptor set. Oh no. We need to have 2 of these. Cool, we're not doing anything cool, we're just reading through some existing GL engine codes to try and massage it into something we can feed Vulkan efficiently. Not great so far though. Right. You used to doing the was it the Half-Life you're doing like a renderer for Half-Life, isn't it? Or is it a different... Ah, awesome. Nice. So, because I remember seeing you've got some stuff up and running. So, is there a specific part of the render, like the renderer that you're trying to port over? So yeah, we're gonna have to make 2 of these. It's not the end of the world. Right, so entries, and it's gonna be a lovely array. We could probably do with a for loop to fill this in. Now we can just... why is there so much programming in Vulkan involved? It's just so much work. So binding 0, array element 0. Wait a minute, the binding's got to be hard coded. Right. So the binding's got to be HCC interop. So this is where all of our storage buffers go. So storage buffer, sampled image, right, so there are bindings. So obviously the first one is for read-only, read-write buffers and all of that. The second one is for sampled textures, and then there's a storage image one for our read-write and read-only storage images or textures. And then we've got a sampler one as well as the final one. So array element starts at 0. The count of them is going to be 1024. Do we need this many? Then VK descriptor type storage. Storage buffer. Now this stride and offset thing, not sure exactly. Yeah, well, so I just want to render models in-game, objects, enemies, etc. Awesome. Okay, more efficiently. which needs knowledge about what is static and what is dynamic. Yep. Group calls together an object. Cool. We're specifically running into the issue of severe FPS drops whenever something explodes and there's too many objects to be drawn. All those objects are dynamic, rebuilding the blast. Oh wow, you got ray tracing. Nice. Is that right? Bottom level acceleration structures? Yeah, yeah, that's right. Typically you want to prioritize a few of them. Yeah. Pretty cool. Yeah, you have to like refit it, isn't it? And then yeah. Very cool. Yes, it's pretty crazy. You've actually dealt with the Vulkan ray tracing API, because it's just another huge complicated thing about Vulkan. Pretty crazy. Hey Perry, yeah man, still here. There has been an update. The wife is all good. She's they've got her high blood pressure down now, and she's coming back. So we're doing good. So right, you got to do this size of buffer info thing. It is okay. Right, so there's a 0 offset into the buffer. Size of VK descriptor buffer info. Right, so we can repeat this 4 times now. Where's the create template one? Why didn't they have a link to it? I'm trying to look at the strides here. Entries. Right, so the stride between 2 array elements. Yeah, it has to be that type. It says that pdata has to be a pointer to valid instances of these types, which is a shame. It would have been nicer if you can just do something else, but okay. Because the image ones are quite big. Well, they're 3 pointers worth. Right, so next one is sample image, which then obviously is sample image here. Then this one is image info. Then the rest of them are image info as well. Yeah, it's all good news around. This one is storage image. They come after. I believe that's still right, isn't it? Yeah, good. Then this one is storage image. Last one is sampler. And then this one is sampler as well. Right, so this means we create this template where we're going to have basically 4,096 elements all stuck together, or they all come one after the other rather. Like this. We can allocate one big load of memory and then upload them all. This is probably not very efficient because there's quite a big number of them and there's a lot of holes. But we can definitely either shrink this number down from 10 to 24 to a smaller amount for this specific game, or we can make each of these the exact size they need to be and sub-allocate them all. Yeah, whichever way it is, we can do that in the future. So we could probably say to do to do in future, make this descriptor update template smaller, so it'll be less data to upload, right? Something like that. Cool. So now we need to actually make two templates, because this one takes in a descriptor set here, which is not fun. So we want to do yeah, active frames, that's it. Right. So template. Oh no, you've ruined it. Update templates. Had to be such a long name. So it's update templates from 0 to GPU. So what we're going to do is we're going to say create info dot set equal, and then we're going to index our GPU VK descriptor sets with the index, poke that in there. Then we're going to call that GPU VK dot VK create descriptor update template. Yep. Now I completely, well, okay, follows the traditional formula of Vulkan. So you pass in device, you then pass in the create information, I think, then the allocator, then followed by the out pointer to where you want the handle to go. That'd be VK descriptor update templates index. Oh yeah. Right. Oh. Wait a minute, there's only one of these you need. Boom. Set. What's that set index do? The number of descriptors set in the pipeline layout that will be updated. Oh, this will be ignored if the is not. Right, so we can just poke 0 in there. Ooh, this will be ignored if the type is not this. Excellent. So all this bind point stuff is to do with that push descriptor. Okay. Excellent. So we can actually ignore all of that. So we only need one of these templates. So set equals 0. Ignored. VK null handle. Ignored. And ignored. Excellent. Rightio. So all it means we can do is just call this directly. Now it probably returns a result, so we do want to call our super lovely GPU VK assert, right? And then nice. So now we've got our update template. We should probably get the memory though. Now I've not used an allocator before. So this is the first time we're actually going to allocate some memory in the system. So we're just going to store the update. So we're going to call right. So we're just going to have our VK descriptor buffer info. So we'll store in our storage buffer, storage buffers, sampled images, storage images, and then the final one is samplers. Very nice. So we actually want to initialize these guys. So we're quickly just going to get that in as well. So we need to allocate our memory. I don't have a custom allocation system yet, so we are going to use malloc. This makes me cringe. To do custom memory allocator, please. So how do we do this? Yeah, please don't tell Don. Please don't tell anyone, Perry. You know what? Screw it. I need to put this in a little local variable. E32. To do we need this many? Descriptors count. So we're just going to copy this. Image info. Probably multiplied by 3. Yeah. Right, that's what we need. So we just need to poke the memory in. And that's going to be ggpuvk dot. We're then just going to say mem. Well, it's just mem, isn't it? Right. Then this one is the address. We'll cast it in void star to get the auto cast. I guess I'm being lazy. So it's be that address descriptor count. Coming from the previous one. Oh shoot. That'll to do it. So we're just basically going to the end of the array, getting the next pointer, going to past the next array, past the end of that array, get the next pointer, and just set them all up. So now we should just be able to fill in each of these every frame, and then just call the update descripts template once, boom, uploads everything and done. But again, probably not like this will be the most efficient when it's tweaked, but it's probably quite inefficient right now, but it will do. So that's good. So now let's actually use this update descriptor with template. So it's going to poke in these memories then. Here we go. So we're just going to go over all of the resources. Index 0. How many resources do we have? Good question. It's not very easy to figure that one out, I don't think. Yeah, this is not good. Yeah, I think we can just get away with it. core array count, because this won't compile when we change it, which would be good. I don't know, will it? Resources cap. Let's put to do label by this. To do change when we add object pool. It's not the Vulkan one, obviously, it's outside of that. So what we're going to do is we're going to go over all of those templates. Depending on the type. So buffer info. Yeah, see, maybe it's not good if... Maybe it is best to sub-allocate. Like... Maybe it's best to... allocate a slot. Just poke the memory in. I don't know. Well, an interesting thing is when you create the buffer or the image, you can just poke the new one in. So they can start off as the null descriptor, right? And then whenever you create an image or destroy an image, for instance, right, you can just poke in the updated thing. And next time you update the descriptor sets, it will just take it all up. So you don't need to do this every frame. That's interesting. That's really interesting. So maybe what we can do is we can initialize those with the null descriptors right away when you boot up the system. And then just poke in the ones we need. That'd be pretty good. Let's do it. All right. Slight change of plan. So back where we initialized that were those null descriptors or null buffer. Underneath here, we're now going to, fill the descriptor template memory. Descriptor update template memory with the null descriptors. So this just requires a for loop. So we're going to be doing 0 to that. We can get those 4 pointers again, right? And we're simply going to be filling. So buffer info, storage buffer, sampled image info, storage image info, sampler info, right? So I'll just get index. And we're just going to fill in all of the nulls. So we're just going to be saying, right, G, GPU, VK, dot, all of that. Now we simply just want to say, right, this one, so buffer is going to be equal to G, GPU, VK, null buffer. Then we're going to be filling in, range will be 0, or range will be VK whole buffer. Then offset will be 0. Okay. And then with this sampled image, the image, well, you need image views. Crap. We need an image view, people. We don't have that on the descriptor that we're going to poke in, that null descriptor, do we? So it's created just above, luckily enough. We'll just quickly amend that. So this needs to be GPU-VK null image view type 2D format R8 G8 B8 A8 unorm. That's whistling one level. Cool. But we didn't create it yet. So I'll go in there as the null descriptor GPU-VK null image view. So we just need to add that one in. Right. So that's in our global piece of memory now. So now we can reference this in here. So GPU-VK null image view. Nice one. So sampler VK null handle, because that's a combined image sampler thing. We don't support those in HCC, so we just don't use them. They're kind of old school nowadays. You just pass off separate sampler objects. Image layout, okay. So this will be in VK image layout. So a sampled image will be read-only optimal, isn't it? It will be read-only optimal. This is so bad. Right, then I guess the other one is in, the other guys will probably be in general. But if it's a read-only one, if it's a read-only storage image, you kind of want it in. But I don't think I want to create another. We'll see. We don't have a null sampler. Can we create a very basic sampler as well? VK sampler. Create sampler. So create the null sampler. Let's fill in this big boy. So typically, I think we can get away with just, like, if we zero the whole thing, we don't really care about anything. So we just need to fill in the necessities, right? So we just want to say, right, the structure type is VK structure type sampler creates info. right? We just want a p next of null, and then we just want a flags of 0. Well, we don't care about the rest. So I think we just need to do that quite literally. And then we should be able to just create rob that, create sampler, null sampler, create info. Right, the rest can go, and that should work. Good, good, good. So this needs to be VK null handle. This needs to be null sampler, and the layout can be undefined. Excellent. So that's going to fill in all the template memory data. So it's exactly what it needs to be. And then we can poke in as and when we create and as and when we destroy. So we've only really got, so we've got buffer initialize. Do we have buffer deinitialize? We don't, do we? No. Okay. So when we create it, you know, it'd be really good if we actually passed in the ID as well. Because then it means we can use that to poke into the descriptors, you know. Source GPU, backend. Buffer initialize. Texture initialize, there we go. So what we need to do is we need to poke into those descriptor things, right? So it's like descriptor storage buffers, right? So we're specifically going to say GPU resource index resource ID index. So that just gets the index part from the ID. And then we specifically just want to say, right, the update buffer is the one we've just made. Right. Then we do the same thing for this texture. We just update image edit to image view. So it needs to be storage, sample images, image view and image view. Excellent. Rightio. So that should be all the descriptors now in memory. So we should just be able to update it in one call, right? So all we need to do now is literally, wait a minute. Okay, this one's interesting. So we've got to update, we've got to poke the swap chain in. So to poke the swap chains, that'll go in GGP. I know I got rid of it, but I think we need it back. We need to have an enum for kind of like the built-in resources, right? Resource index surface, right? So these are the built-in ones. So start off with 1 or 0. Yep. Resource index for the upload buffer. Right, we'll also need one for a readback buffer. And then we also need one for a readback hprintf buffer, right? Or just call it hprintf buffer. So, yeah, that'll be super handy. So we'll have a thing where it says like user start, I guess. Well, this is where the user wants to start. Awesome. You know, maybe we don't need the numbers. So what we need to do then is we need to say, right, vk dot for the sample images, well, only storage images. For this one, dot image view needs to be set to vk swap chain image view. So you're poking in that descriptor into the memory. Next up we need, what else do we need? We want the upload buffer to go in, right? So that one can kind of just be set when we create the buffer itself. So that'll be a buffer GPU VK upload buffer. So when we create that, which is here, we can actually just poke it into that memory, which would be super nice. Well, maybe we create this after we've made the descriptor stuff, actually. Let's move this down here. And now we create the upload buffer, then we'll create the readback buffer as well. Then we poke the descriptors in. Yup. Getting good now. Right, so I think that's it. Now all we need to do is call that ggpuvk.vk update descriptor set with template, right? Pass in the device. Then I'm pretty sure it's the descriptor set. I'm just gonna have a look at that one. Yeah, descriptor set. So that's wait, where is it? Right, GPU VK descriptor sets. Where's the active frame index? There it is. So that'd be 0 or 1 basically. It just paddles between the two. Between every frame, it will go swap between one and the other one, because one is being used by the GPU while the other one's being used by the CPU. Then we want to pass in the descriptor update template, and then we can finally pass in the void pointer where we'll call it data. Terrible name, but we'll call it data. So we need to make sure we actually set that. ggpuvk.this. So it gets initialized here. ggpuvk.equal_mem. Right. Super good. So it's just one call to this function, this update descriptor set with template, and it'll update all the descriptor sets. Sorry, all the descriptors in that descriptor set, which is super nice. Like, and that should be, you know, we're not calling into the Vulkan driver 4 times. We're not calling into it 64 times or whatever it was going to be. We're just calling into it once per frame now. But the only problem now is the fact that the template is so big. Like, it's 4096 descriptors. This is not as good as if it was maybe only 1,000 or maybe 200, right? Depending on what this game needs to be, we can definitely bring that down. But yeah, this is still like, it is the shape of the code that we want. It's just the data is maybe not necessarily the exact shape that we want, shall we say. Well, yeah, kind of. Okay, so that all compiles somehow. We've made all those changes, just compiled, so there we go. Now, yeah, so let's see if this works. Right. So when we're creating our null descriptor, I guess. Right, which line is that? 685. Yeah, it's the null one. Right, so this one says unorm, but I think the one at the top says snorm, you know? It's not snorm, it's unorm. Keep getting those two mixed up. There we go. Right, so we're now running a frame and then it crashes. Descriptor writes... Oh no. What? Is it using the descriptor write API underneath? So this update with template probably uses the descriptor write API underneath by the looks of it. That's funny. Attempting to write... Maybe because it's the validation layer stuff. Right, attempting to write a buffer descriptor with usage mask 1, but does not have storage buffer usage bit set. Is that the... Ooh, was that the upload buffer, do you reckon, that we made? Ha ha ha. We didn't put the storage buffer bit on it because I initially wasn't thinking we're going to access this from the compute shader, but we added an API so we can do that. Have you been able to watch your streams lately? Hey there, Indifferent. What are we doing today? So we've added support. We're adding support for the upload buffers, so we can upload to textures and buffers. So the stream before, we were doing synchronization code. So we've now added so we can draw so we can now sync some resources and do multiple dispatches now. So we can run more than one compute shader and it should work fine. But then the stream before that, we added support to create buffers and textures, but we haven't tested them. And we haven't been able to use them because the only way we can use them is if we write to them from a compute shader, and that's it. So we want a way to upload data to them. So we're trying to get that working today, which it should be working very soon actually, because we just got it all plugged in. And so we've got this upload buffer, upload to texture, and there's also this upload manual which we've added, which just simply, oh boy, why does this thing never zoom out? But yeah, so essentially like we have a host visible thing that like region of memory that we fill in when we upload some data, and then you can maybe upload another piece of data right? And then if you say upload buffer or upload texture at the start of the next frame, it's going to essentially take that thing and then upload it into the correct place in the buffer where you told it needs to be uploaded to. So we've got all that code in, which is sweet, just not tested yet. But also I've added another thing where you can say upload manual, where it just means, hey, I'm just going to write into this void pointer so it puts it in the buffer. And the best thing is you can now read this upload buffer in a compute shader, which means you could essentially do a custom copy where maybe you need to translate the data in a compute shader into a buffer, right? So you can run it in a compute shader and translate the data on the fly on the GPU. So, and maybe you can decompress it or something like this, right? So that'd be interesting. Haven't been, sorry. They're still using STL, what a shame. I know, right? Like this is why probably why the Vulkan validation layers are like create such an impact. I've heard people say like they basically have to emulate OpenGL and do all this in a way and do all this tracking, but it's like I remember seeing them doing like tons of different allocations and maybe even using like standard string. Yeah, they're even using like string stuff and all this stuff, and like maybe then it did it when they log, so maybe it's not so bad. But I can just see that these in unique pointer, their compile times must be terrible for this thing. You know, it's crazy. Anyway, I've drawn the same thing like a million times, but it's amazing. So yeah, that's what we've been up to. So we're just trying to get it working now. So if we rerun the compiler, compiles right away. How you expect the code base to actually work. And this next one is saying, when it writes to the descriptor set, failed to write sampler descriptor, invalid sampler. What are you talking about? Did we not set the null sampler thing? It's right there, man. Ooh, did we say sample shared sampler image or? This is interesting. Let's see. When we made this template, did we use the wrong one? No, sampled image is the right one, isn't it? Because there's combined. Yeah, combined image sampler. We don't use that one, which we're not. So that's fine. So what is the? So there's just it's so wordy, right? Attempting to write update to sampler descriptor with invalid sampler this thingy. Spec states if the type is sampler or combined sampler, descriptor set was not allocated with layout that immutable samplers for destination binding with type. What is this even saying? The member of each element of because it is. Right, let's read this again. Let's understand this rocket science. So binding 3, which is the sampler one, right? Failed to write. Right, so let's make sure the pointers are set up right. So this one is set to memory, so we allocate enough memory for it, right? It's just that times the number of these plus this times that times 3 because there's 1, 2, and 3 of image sampler info. Sorry, descriptor image infos, right? Then this one is the start of the memory we allocated. This one is right after the previous one. This one is right after the previous one, and then this one is right after the previous one, right? Not rocket science. Let's just make sure the types are correct. Image infos, yep, they're correct. Then let's follow this. So you go over all of them. Oh, this didn't change. Sampler info. There's the problem. Right, moving on to the next thing, hopefully. Same error. It cannot be. Oh, this one. Right. So same error, I think. If the type is... So attempting to write a sample descriptor with invalid sample of this thing. It's actually got an address, which is interesting. We could print this out, right? Just use printf. P. Let's just see what it looks like, right? You know, I do this so many times, and we are doing a custom code base, so we could just have a thing which says print value, and it does this automatically. Maybe. So I'll think about that in the future. So that's not the one that we got. So it's reading into some different data, I think. Yeah. I know, right? When you think you know your code. Right, the green screen is looking good. That's good to know. So descriptor set is allocated with a layout that's immutable samplers. Did we not? Let's quickly have a gander. Sampler. Right. Now, maybe we buggered this one up. We couldn't have buggered it up. Did we bugger it up? Maybe in the interop layer we buggered it up. Let's have a look, shall we? Third party HCC interop. Where's the sampler? It's got the script type sampler there. Pretty legit. Thank you. Thank you. I love my shit too. It's amazing. It's beautiful, isn't it? Oh. Yeah, it got brought by my wife's mom when she went to Kenya. She brought this back for me, which is proper cool. Right, the Vulkan spec states if descriptor type is sampler or and destination set was not allocated with a layout that included immutable samplers. Right, okay, immutable samplers are a different thing. Full destination binding, yeah. The sampler member of each element of P info must be a valid sampler object. Aww. What are you talking about? Because it's storage images, then samplers. Why? This is all correct. How hot is in the UK? I don't know really. It's been... I haven't checked specifically, but it's definitely quite warm. It was definitely warmer the weekend. Last weekend, it was like near enough 30 degrees. It's probably 25-ish now, I reckon. It feels 25 or over. It's probably not. Yeah, not sure what it is now. We can have a look. Let's have a little gander. I'm just gonna look at my phone, so I don't accidentally disclose my location. So right now it's 20 degrees, and it's like 8:30. So these are looking good to me. The null descriptor is definitely set. Awesome. Yeah, apparently Sweden gets quite like, depending where you are, it gets quite similar weather to the UK. I think more the south side, right? We're setting sampler here. So what's interesting is, could we see this? Oh, this would be a good way to see it. Does the debug info give us a pointer to the image infos? Right? Does it tell us that? See, that number feels wrong to me. Oh wait, is this the right? P descriptor writes. Update validation set. Write to descriptor set. Okay, with this layout. It's not giving me the pointer to the P image infos. So I can't compare it. Yeah, it will be much more warm in your room, especially with a PC on, you know. The little heating device that it is. It's interesting that they use the descriptor rights. It looks like they're creating tons of them as well. Looks like it's not very efficient. You'd hope the implementation would have been better. Thank you, Don. What's up? Welcome, Don. How you doing? I know what you did. What was that, Don? Oh no, Perry. What did you say? Was it Perry? Did he phone you, Don, and report me? It's my first time, Don. Don't. It's my first time, Don. Don't. Please don't harm me. Where is this sampler? Are we setting all the sampler memory up to null samplers? We are, aren't we? He sends them across the sea, yeah. I see what you did there. You just tapped into my key presses. On this beautiful and wonderful Mac keyboard from 2007. Read 'em and weed. I still don't understand why this is being a problem. Yeah, I quite like this old one. I'm not sure about the new ones though. Did we allocate enough memory? We've definitely allocated enough memory, right? That times that. Then times by 3. Right, and then it's starting at, like, that number there is 1024 times 3, right? So it's the one that we expect it to be. The stride is all okay, I think. It's not about the stride though. Oh, there's an offset. This offset could be the problem. An offset from P data it might be, right? This is probably it. In the raw data structure, would you look at that? Would you look at that? This is the problem. So this needs to be, right? Oh. Screw this thing. Right, this one needs to be times by 0, times by 1, times by 2. What a piece of work that was. It works. Kinda. What has happened? So we can fix this in RenderDoc. But we need to use the custom version of RenderDoc because I don't know if they've released the patch yet. So let's go into the custom patched version of RenderDoc. It will come out. It's just it's in the latest Git. We just need to game over engine build. Yeah, so if you're going to use, yeah, you need to use 1.27 of RenderDoc if you're using it in this code base. What's the latest version? Oh, they released it 2 weeks ago. Okay, so it's got the fix in it, right? Right, we can sort of see what's going on. We need to capture 2 consecutive frames. It's not even doing that, is it? It's not even coming up with the thing on it. It's not coming up with ability to press F12, is it? So this is just gonna like jump between 0 and 1, because that's just the way this thing works. Oh no, okay, let's say GGPU VK frame index. ZU. So the frame number's going up. We can't even do a capture for some reason. I don't know why. Right. I think it's loading the wrong descriptor. So if we go into... No, it's doing take 1. So it initializes it to 1. Should be GPU. Surface index, right. Offset in bytes, stride in bytes. Pretty good. Did we remove... No, it can be... Let's poke sampled images in as well, just in case. Yeah, it'll crash, okay. What is it doing? Let's see if we can load up and render doc again. I have no idea why that didn't work before. Oh, we need this thing. That'll be why. Right. Oh, come on. Oh. HCC error? What's he talking about? Sync resource 118. What did we just change? Sorry, 188, that's what I meant to say. Huh. Right, now we're getting a different thing? We getting oh. Right. Are we trying to sync on a resource that's with a null? Oh, wait a minute, I changed this, didn't I? Okay. Right, we're back to here now, it's good. Go back to render doc. Excellent, so now we can do the capture, finally. So I wanna queue up 2 frames consecutively. Yeah. So we're seeing it. Can you see? We get it, don't get it, don't get it. So we're gonna load this one up. We're gonna take a look at the different dispatches. Oh, it could be the barriers. So we're first going to look at the pipeline state and just check our descriptors. Make sure what we're writing to is really actually there, right? So we're trying to write to this image here, which is the read-write image. Yep, the descriptor exists, right? It's in 1, that's the surface, right? Wait, it's in 1? I thought it's in 0. 2 seconds. One by one texture. Can you see that? So 1 by 1. That's a null. That's the null descriptor, right? Same again. So why are we indexing with 1 and not 0? Because we put 1 into the... Ooh. Right. I think I might try and do this... Should we try and do this automatic sync code now? I think. I know we're just doing tons of different features, but they all end up getting each other working. Hey there, T-Cap. How you doing? Welcome, welcome. You have the power to clip it. How did the stream go? Thank you. Thank you for the raid. Welcome, raiders. Working on a game without an engine. And we're currently getting the graphics side of things up and running directly using Vulkan. We're trying to use compute shaders only, so we're just trying a little abstraction for that, really. We're currently working on the upload buffers, so we can upload data to the GPU. How did the stream go? So what I think I want to do is automate. So the thing is we do .raw here. We set the bundle constants to that. But then we give it to the shader, and the shader's using like this is an ID, but what we really want to do is set the index. Yeah, I guess that could be the workaround. But I don't have to keep doing it. So in the background, we could probably... Well, so I think we're going to have to say GPU that, right? That's the solution. And I was thinking we could probably do automatic sync code and get this line to be removed here by reading it from the reflection data from the shaders that we get. But yeah, I think we'll do that very soon. Let's just get this back up and running. Oh yeah. So this is what we have right now is just have a compute shader running at the back. and then a compute shader running in the front, cutting out a triangle shape. So yeah, now we want to try and actually upload some data. So what should we do? Well, what we should do is actually make a you know, I should try and learn ways to do this quicker. Yeah, so then I can go, and then I can say, much better. So I want to make a new global structure. GFX, GGFX. Now, what we're going to do is we're going to create a texture, right? GPU resource ID. So let's make a logo texture, right? So this is the thing we're going to make, and then we're going to upload data to it, and then so when we instantiate our graphics system, we're going to use GPU texture initialize debug name logo. I kind of forgot the rest now, but it's probably width, height, depth. Wait a minute. Let's grab this with us. GPU resource type texture 2D format GPU format 888. See, that sRGB should be destroyed. We can't support sRGB. You have to do the manual conversion yourself in compute shaders. Dims. So what's the dimensions of this texture we're going to read up? We'll just do the 256, 1, right? Yeah. MIP levels 1, array layers 1. Excellent. So what we want to do is now we want to upload data to it, right? So we do have that super lovely. So here's our upload buffer, GPU upload buffer to texture, ggfx dot logo texture. What's this? Then there's an offset, isn't there? Offset dimensions MIP level array layer. So basically 0. Then basically the whole size. So I guess we could do a thing where if we say 0, we mean do the whole size, but that's something we can do in a minute. Let's just get it working first. So I think we want to say, yeah, the MIP level 0 and array layer 0. So now we want to do a simple mem copy, where we're going to mem copy. So we'll use STB image, we'll get in the data, right, the image data. And then it'll be something like, what's the number of pixels or image size, something like that, right? And then that should, when frame start is called, it will record that into the command buffer, right? So you can call it in the initialization, but you can also call it before frame start every frame and upload some data. So very useful API. So now we're going to bring in the legendary library STB image, which is a nice little single header library that you can use to you can use this one to simply load JPEGs and PNGs and some other images. Bastard. Right, so now it's in the third-party folder. It's just in the repo. Super nice. What we want to do is bring it in somewhere. So I guess we're just going to go into the main thing, and then we're just going to go define. Well, it's really bad. We're doing single compilation unit at the moment anyway. Yeah, we'll put it at the top. Define include STB image. Define STB image implementation. I think that's it. Yeah. So now we just need to use the load from file, and we'll load specifically so we could just bring in a logo temporarily. So why don't we just get a yeah, where is my logo for my... Right, should we get like an assets folder? Hey there, Avid Runner. We're working on a game without an engine, but we're just building the engine part of it first. So we're just building the graphics side of things directly using the most the most annoying graphics API, Vulkan. But it means we get access to the GPU. And yeah, we're just currently working on the uploading data to a GPU resource like a texture. So we're just loading in an image right now, and we're just going to see if it all works. And then we're probably going to work on having printf working from shaders as well, because we have it working in a sample program. So I'm just going to get that set up so we can print from any shader. But yeah, we're just working on the engine part right now. When we have the GPU stuff working, we'll be coming out and doing more, like doing other areas. So we're just going to build enough so we can find an art style by programming some. We're going to try and find some unique. Well, it's going to be we're going to try and be as unique as possible if we can. But we're going to try and find our own sort of like art style just by programming some 3D graphics, and we'll see how it goes. How can you print from a shader? How can it be possible? So I've made my own shader compiler called HCC. C compiler that compiles C code into SPIR-V so we can use it in. So this is a pixel shader. It just renders a triangle to the screen. State-of-the-art technology. And then at the bottom, so this tests out the swizzling code. At the bottom we have a custom printf, and it will essentially write out to a buffer. So it writes out to this buffer called hprintf. The first word of the buffer is an atomic counter. The second word is the capacity of the buffer. And essentially we take in a string here, and then we turn that into we write that in as 4-byte word sizes, and it pads it out at the end to the nearest 4 bytes, right? And then we encode the arguments in after that as well. And then we read that back CPU side, and then print it out to the terminal. Yeah. So it's pretty decent. So just to show you a demo of that. There it is. So every pixel, well, yeah, every pixel basically writes to here, but then it fills up and then it doesn't overflow, and it prints it out the values that we requested. So yeah, super cool. So this is something that we definitely need when we're going to be running a lot of GPU code, right? So it'd be super, super handy. And it's pretty easy to set up, I think. Well, yeah, I've set it up before. It's pretty decent. No problem. No problem. And if you want to check out the code, it is up on my GitHub. If you're trying to figure out like how I've got it to work behind the scenes, so I can just drop a link into the chat. Essentially, there is a standard library in HCC intrinsics, and the function is in HCC shader, the hprintf macro. So it's a macro basically that we do that does it all. So obviously it's not the most like efficient thing to keep doing, but it's for debugging, so you don't really care, right? Right, so STB image. We should now be able to. So I think I had a logo. Oh yeah. So let's get the 256 one. Let's bring this into the repo. Logo 256, right? Excellent. So we're just going to be using STB image, right? From file. Wait. Load. STBI load. Right. The file is in assets logo -256.png, right? Get the width and height back out. Wait, int width height, yeah, buggers. Yeah, width height, channels in file, components. It could have just been a structure, but anyway, yeah, right. Desired channels 4. Excellent. So what we need to do now is we get back the image data, which would be a U8. And then we just want to simply, you know, we could probably assert this, but I don't really care. Well, let's assert. Failed to load image. So now I get the pixel data. U8 star to unsigned. What? Is it just a char then? It's an unsigned char, you bugger. We'll see what it says in the compiler because I can't read that message. But the size is simply going to be width times height times 4. Oh my days. Right, I'm gonna have to fix some errors in, because I've got some extra conservative, I guess, errors where, well, a very strong error stuff that goes on. YouTube is pissing me off by deleting my comments. I was trying to help someone with issues with Clang not compiling with Visual Studio. Oh. Strange. It's not. I guess it's not really the place to do it, is it, on YouTube comments section? But fair play. Right. So we've got this damn implicit fall through thing. We could probably just push and pop and disable it, but damn it. I could probably do a separate compilation thing, and then get it to link together. There's the funny thing is there's a comment there that says, right? What have we got a fall through thing? We haven't. We need to use. Right, here's what we're gonna do. So we need to open up the main. We're gonna include core H. Close that. We're then gonna open up core H again. We're gonna define core fall through as __ attribute because that's what it needs to be, because C until C23 doesn't have it. This is Clang's way of saying it, and you basically if-def this to be something different on each platform, and maybe do nothing, right? Clang attribute. Maybe I typed it wrong. What's the C version? Ah, and extra brackets. Because that was so obvious, you know. Core fall through. Just whack that in there. Cool. That should be the fixes we need. Let's just jump around, do some more bits. So we remove the sRGB thing because all that format specifier does in the end, this underscore sRGB. All this does is, like, when you sample the texture, it just does the sRGB conversion from sRGB into linear in the shader. Then you work with it in the linear space, and then when you write out to it again, it converts it from linear into sRGB. But yeah, we don't get that automatically with compute, unfortunately, so we're just going to remove it. I can do push pragma clang, ignore that, and then pop it. I could do actually. Yeah. Hmm. Yeah, it's hard. I was thinking that. But yeah, I think the edit's not so bad. We can just maintain that. And maybe I'll do a separate compilation unit later. But yeah, I'll think about it. Right. Okay, so we're compiling now. So we got some problem with the memory barriers. So it's the great thing is it's actually doing the it's starting to do the upload stuff now, which is good. So in frame start 1081. So when it does this one here, which is specifically, ooh, now we've copied the uploaded data. Interesting. So stuff above is fine. Transition it back out. So it's saying that the cannot transition to undefined or pre-initialized. Spec states blah blah blah. So right. Damn, what a bugger this is. So I think the image layout should always just be general. Shader read only just sounds problematic to me. Read only optimal, it just sounds really yeah, so I think I want to get rid of this. We're just going to do general layout. Maintaining read only optimal just seems too much work. So that means anytime when we do a destination layout, sorry, new layout, that's what it's called. This one. Thing is, it could be undefined. Yeah, you know, I might have to keep that around. That's not good. Oh. Yeah, I'm keeping this thing around. Okay. Right, let's try this again. So yeah, so if the old layout is undefined, we need to know that. But if the new layout, we are just going to do VK image layout general. And we're going to fully old layout. What's this one? New layout is probably always going to be general. Yep. So this read-only optimal is going to go. We're just going to stick with general because maintaining read-only optimal is just a pain. In the future, we think we can have a bit of a play and see if there's a speed up we can do. We can try shader read-only optimal and see if there's any difference, right? But for now, this just makes it easier. Okay, so now we're running. So we've updated the apparently we've written the buffer update, but we don't know yet. So now we're gonna write some shader code and get that thing in there. Hey there, Twast or two-step. Got to use strict flags with C, maybe called pedantic. I'm using pedantic. Like I always use pedantic. It's pretty good. So I have to use this version of C, right? The G and U version of C, but then I use the pedantic flag. You have to use G and use C on Linux if you're doing anything with the system, basically. I have the float conversion error. So we have to be explicit casting between integers and floats. Implicit fall through, we warn when that happens. Very, very good. And I get all the extra errors in as well. Oh, I see. I see. Thank you. Ooh. No, these are all fine, aren't they? I don't know why it's complaining. Oh, right, I know why. Because we've not included STB image here and it's not being able to pick it up. There you go. Then I got mem copy in here technically. I really don't want to include like libc headers. So we're going to be doing a pass to fix all of this. This is standard, or it's in string. Yeah, I think we want to wrap it all into one compilation unit and just pre-compile it once, and then the rest of the compilation units won't use libc headers. So we should be able to get the header files down to something small, hopefully. What? What are you talking about? Redefinition. Dude, don't you have pragma in there? Oh, wait. I know why. Undef STB. Yeah, well, we're still going to have libc, but it'll just be wrapped in a... We're just going to take the bits that we need to shrink our header includes is all. It's nothing too exciting. Like, as the project grows, we just want to make sure we have fast build times is all. And we will take a pass on that before the codebase gets too big. Cool. So let's go ahead and draw an image, shall we? Should we do a new shader? Be fun. So we're going to write to the output. This time I'm going to write the logo. Very specific code. So we're going to write out, we're then going to have a sample. Well, let's not sample it. Let's just do a read only. This is the logo. And so let's draw a logo. Right. So we simply want to just check if you're on the out coordinate sv dispatch index.xy. Then if we're outside, don't do anything. Well, you know, we need an offset. I want to put it smack bang in the middle. So maybe we follow this thing. logo half dims. Right. We'll do an S thing on that so I can, maybe, we'll see. We'll do a position. All right. I'm from the UK, Kent. How about you, Rattletrap? Welcome to the stream. So this number here, BC, half, come on, logo half dims dot x. So we've got the offset. Wait, do we want that? Right, I think what we want to do is say coordinate is simply a subtraction between SV dispatch. Oh, come on. And we're subtracting BC logo half dims. Right? So if the coordinate goes out of bounds, wait, where's the position in all of this? Good question. So it'd be BC, I'll add G, BC, pos. Excellent. So that goes outside the output texture complain. Then we're going to sample our pixel. So we're just going to say load texture G. We're going to load from the logo texture. The sample we're gonna, like, the sample coordinate is gonna be what's it? It will be So I think you want to get output chord, and I think you're going to do another one and call it logo chord, which will be the subtraction between the output coordinate and the lower left. Right? So it'll be that. I completely forget. Yeah, that's it. And then that should be it. Right, see how well this works. You're from Russia? Cool. Why is this complaining? Right, we didn't say .xy here, that's why. Then this one's complaining because logo texture field cannot find. It's just called logo, that's why. Logo. And voila, it compiles. But we haven't actually dispatched the shader yet, have we? So we're just going to go over to, let's take this with us. And let's hop back into this one. Let's copy this guy. I'm going to copy guy. and we'll change it to logo. We're going to have an output of that, output dimensions of this. The logo is going to be GFX logo texture ID, the one we made up top and loaded in with STB image. We need to do that GPU resource, this thing. Then we need to say BC output, no, logo half dimensions. I think we'll just do a U32 times 2 and just do 256. We'll just hard code it, right? So then we just need to launch the shader with this shader info here. So essentially we get some shader metadata and it produces an enum for us. It's pretty dark here, isn't it? Oh, it is. Although we'll fix that. But yeah, so that should be it's meant to work. Alright, we'll look into that. Yeah, I guess. Yeah, it's quite a terrible situation, isn't it, with the whole war stuff going on. It's not good being on either side of it, is it? Yeah. Well, I hope things kind of resolve your end, or maybe you can find a way to a different place, because it's pretty sucky. Oh, we didn't copy the whole thing. It's very problematic, this API. Oh, come on. We can boot up and render doc though. Can have a look. Did the music stop? Right. So if you see here when we launch it, it's done a couple of captures for us because I told it to. But on the first frame, there it is, the buffer copy image to buffer to image, right? So shall we take a look at that image, right? There it is, the logo. All in the compute, all should be viewable now from the compute shader. So this last one here, oh, we're not running enough. We're not running enough pixels, are we? Probably why, I reckon. Should we up that number and see, or should we take a look at the pipeline state first? Compute shader. Where's my bells and whistles? Where's my images that I access? Output, yeah. Those are good. That's good data. I should be seeing descriptors here. See descriptors here. So the reason why I probably don't see a descriptor is probably because it goes out of bounds in the shader and then it fails. So that's what I'm assuming. So there's a few key issues here. The first issue is we're not launching enough. Right, we need to launch. Or maybe we're launching too many. I forget what it is. $256 divided by 8 rounded up. So that should launch enough compute shaders. Now, in here, Oh, that subtract definitely goes too big. What we're meant to be saying is, hey, add the dispatch index and the position, which will offset us into the texture, and then take away the heart. Yeah, because if not, it's going into the negatives there. Right, that should fix it. Too many parentheses. Oh yeah, not quite where we want it, but it's close. And we're not going to need alpha blending, of course. So we can do a simple alpha blend. It's not really blending, right? If the alpha equals 0, don't do anything, right? So should we try? What are we trying again? Yeah, we want to move the offset. Why is it? It should be centered, right? So it's 400 by 300. Oh, I didn't say half dims. The half dims are 128. That's why. You bugger. And there we go. That could have been smaller, really, couldn't it? Now we know that triangle's not really in the middle. That's cool, we got uploads working, right? We can upload a texture. So, that's super great. You know, we could just double check it's been... So we go to the second frame here, you'll see there is no copy. It only copies once, and it persists. That's super awesome. Yeah. So something we're missing is an API to get the upload buffer res ID. Right? We're missing that. GGPU. Sweet. Right, what else do we need to achieve here? Yeah, I think this API can be made better. I don't know if we want to make it better right now, though. Should we see if we can get the printf stuff working? That'd be cool. It would be great if you could display your keystrokes on stream. Help us learn Vim better. I'm not sure. I tried. I did it before, but I think it won't do it justice because my Vim is completely custom. I use a Colmac keyboard layout. I've completely made up my own Vim bindings. So yeah, I don't think it's going to prove much use, really. And why do I still see... Right, because the black is not really black. So maybe we'll just do a little cheap... Let's say 0.3, see what happens. Oh, no. No. Well, it's not really alpha, is it? It's the overall color. So you could say like if all G, right, less than G, less than SG, do we have one of these? Oh, it said dot A. Right. Well, let's do 0.7. Let's go a bit high. What? You shouldn't expect to see anything render there. Is my less than functions just all wrong? Ball less than less than. Seems pretty good to me. And I'm saying if they're all less than. Right, now it doesn't show. Oh, the alpha is 1, isn't it? Right, I know why. Dot XYZ, or RGB. Bam. There we go. Very poor alpha discarding. Another suggestion, could you change your stream to 30 FPS instead of 60? Sometimes it gets stuck for me. Not sure if that's for everyone. Interesting. Yeah, we could do that. I upped the stream quality. Yeah, I've updated the stream quality. And maybe being 60 is just too much for some people. And you know, being 30 FPS isn't that bad when we're mostly programming, is it? Yeah. The question is it... Take a look at the settings. We're in the advanced mode. Right, we're on 60, yeah. Yeah, I'll think about that. I think that sounds sensible. Right, so what should we do now? Should we commit this code, I think? I think it's a good state, isn't it? We'll commit this code. So git status. Yep. Git add dot git commit. So we've added add upload buffer support. Git. So I want to change my... How do we move a tag? How do we... Because there's a tag for day 5. Git move tag to another commit. Delete the tag and then remake a tag. Okay, got it. So I want to delete day 5's one. Git dash or tag dash d tag, or sorry, day 5. Okay, then tag day 5. Oh wait, can we do a log? Git log. So the commit I wanted to do on was on fixed for the Windows fixed build that we did. Oh wait, there's a new one. Yeah, I need to do a git pull now. We've done a commit, isn't it? Yeah, git pull. Right, delete that tag, it's just done. Yeah, so hopefully I've fixed my git errors, so I can just, oh no. Yes. Excellent. So we should be able to do a git log. So basically I want to put it on... Let's just make sure it still works. Yep. So on that fixed Windows build, I'm going to stick it on this one. Git tag day 5. This one, please. And then we're going to do git tag day 6. On to this one. Now git push dash dash tags. It still doesn't work. It's so annoying. So go into bash now. I've got to do that eval thing. I've changed it to ID RSA. Type in my password. Push it with all the tags, please. Right, I've got to remove the tag from... Remove day 5 from the remote. Suggest origin as well, and that should... Let's try that one. GitLab or GitHub? What are my opinions? I use GitHub if I'm doing an open source project, but if it's a closed source one, if it's a closed source project, I'm doing GitLab because I couldn't get it to work with GitHub. I'm not a big fan of Microsoft, but just the like, you know, where everyone looks for code is GitHub, just where it is. So, you know, and if you're like applying for jobs and they take a look at your code, GitHub is just, or at the time when I was doing that, was just the place. Right, so for those who have access to the code, you can now hopefully go and download that from the repo. But also there's a link there if you guys want to get access to the code, or there's instructions at least how to get access to it. I have to sign in. Alright, whatever. Let's do a git log and just take a gander. It done it again. Like, it's not updating the main branch. Finally. So tags only did... Yeah, there we go. Okay, we're in. I've pushed constant structure with 4 vec3s on CPU and shader, and the validation area is led as much. Right, you need to use scalar block alignment. What shading language are you using? So in your Vulkan backend, you want to make sure you enable scalar block alignment. Sorry, scalar block layout. On your Vulkan 1.2 features, right? So you daisy chain those together when you create your device, right? And that's part of the pnext right onto the features, and the pnext links to 1.1, that links to 2, and you enable this one, and then depending on your shading language, you also have to enable scalar block alignment. Are you using HLSL or what are you using? So the ABI is just different, right? It's the standard 140 or standard 130 rule. 430 rules. And the way you get around those is you just use scalar block alignment, and then it's the alignment is just like it is as it is in C and C++, right? For the most part. So you just use this and it just works. If not, you have to follow the traditional GLSL standard 140, which is the old school way, then the standard 430, which is for uniform, no, they're for storage buffers, and for push constants use 430. So you have to read into that if you don't use scalar block alignment. But if you use scalar block alignment, which is supported on all new devices, it's amazing. How long does it take to get started with game dev if you're already a software engineer around 7-8 years experience and able to guidelines also? Yeah, I know it's a big question. Like, it's probably going to take you, like, it depends. What do you want to do? Do you want to write? Do you want to write the well? Like, what part of the game do you want to make? Do you want to use an existing engine and write a game using their tools, and just like your main objective is just to make a game, or do you want to like do some do you want to program like the game systems? Do you want to program? Do you want to do like networking code? Do you want to do engine code? Like what do you want to do? Right. Next thing. We need a readback buffer, right? So we can get our printf working in shaders. Very essential thing we need. Very essential feature. So we're going to make a new buffer, and it's going to be called the hprintf buffer. Ta-da! So we need to go into GPU Vulkan backend, and where we create the upload buffer, we need to also create the where's these other memory types created? I see, I see, I see. Yeah. You know what, we're gonna move them kind of together. I think it'd be a good idea. Storage transfer destination. This is transfer source. Right, so this one's for the upload buffer. We want to do another one for a readback. Readback buffer. So the memory type that we need is host visible. We would also prefer VK memory cached. Right, host cached? Host cached. Yep. We prefer it to be, probably prefer it to be device local. I think we prefer it to be device local. So the GPU can efficiently write out to it, and then we read that thing back. I think, is that right? Devices, let's just look at like a 3060 or something. No, not laptop one. What are you talking about? What are you talking about? Memories. Right, so cached. Right, I guess not. Oh, we didn't do the flushing. This is what I forgot about. That isn't gonna work. Oh, I knew I didn't have something written down. We didn't flush the cache ranges for the upload buffer. Right. We can sort it out. Right. So before we carry on, let's get that flush. So we forgot to flush the flush maps memory ranges. This thing. So basically, in our let's go to our where's this called? This is called next to probably the barrier. It's called near the copy as well. Yeah, we'll stick it at the bottom here. Right. This thing needs to be called before, well, probably at the in frame start, which seems to call it. So what we're saying is we have written to some CPU. Sorry, the CPU is written to some memory, and the GPU needs to be aware of that and flush its caches. So all we need to do correctly when it's a Oh, no. That'd be fine. GPU resource index surface. Cool. Right, so we just need to put this in a GPU VK assert and GPU VK dot device. We're gonna have one range. Let's get the memory map range. Sure. So flush the caches for the upload buffer. So we've written to the upload buffer, so the GPU needs to flush its caches. Memory range. So the S type is obviously VK structure type. Mapped. Memory range, P next is null. Memory would be GPU VK upload buffer device memory. The offset is 0 and the size is the... you don't need to flush the whole capacity of the buffer, right? We can simply use the cursor that we have in here, upload cursor, right? So we just flush that range. Now I think this has to be rounded up to the nearest something. What is it? Or it has to be the whole buffer. Ah, that's it. Glorious, sir. Thank you. You've got it. So we need this bugger. Yep. So it needs to be rounded up to the nearest this. I think that's right. Let's just double check the docs. It rings bells, that thing. Yeah. So the memory range has to be to that or the whole size of the whole buffer, basically. But so if you fill up the whole buffer, so this is in the limits. Where's our limits at? Limits resides in the properties. Did we take a copy of that? Come on. No, we need the properties now. Yeah, this physical device data needs to be done better. Like, there's so many more stats you probably want. But whatever. So basically what I want to achieve is like, I want to take, so we'll say like U64 and we want to do like a round up a line. Core roundup alignment. So I think that'll be a power 2, isn't it? How do I close it? No. It's the same docs, isn't it? The size and alignment in bytes. The bounds and current access to host memory. The value must be a power of 2. Excellent. That's what I wanted to know. So GPU VK physical device properties dot limits dot this thing. Bam. So because it's a power of 2, that means my buffer size is a power of 2 as well. Then it shouldn't be a problem. But we should... Right. Within this, each set of bytes in the range is flushed if any bytes in the set has been written to. Right, so you have to align both the offset and the... Right, okay, I see. Right. Interesting. So I'm right. It must be whole size of the offset must be okay. So I guess the thing that we should do is we say if upload buffer size is greater than. We're just gonna be safe here about this, right? GPU upload buffer cap. Then upload buffer size equals VK whole size, right? Because that's the other way of doing it. So that should be all the things that we need. And voila, there's the fix. So the last one wouldn't have worked on everyone's systems if it didn't find the coherent bit, which isn't good. All right. So there's the readback thing there now. Post visible and cached is preferred. So what we need is the ability to create the hprintf buffer, won't it? So let's create that quick. Look for the word upload, hprintf buffer. We haven't got the capacity yet. Should we go and get that? So hprintf buffer cap 8 megabytes. Hprintf buffer we also want to map the memory. Right, so that descriptor set will be there as well. Excellent. Excellent. Well, we got mapped memory range. Should we go and we can get that? That'll be in the hprintf buffer. Oh, I've got it there. Cool. I thought this was there. Oh yes, it's a readback buffer, isn't it? We'll get that in there. Right. So now we should have made the buffer. We've poked the descriptor set in the storage buffers, right? It's right there. So now what we need to do is make sure that this next ID, damn it, oh, right, that should have been, that's extremely poor. Let's fix that. So we need to have like a temporary next resource ID. We'll start that off as something sensible. So we'll say GPU resource index user start +1. Yep. And then there's a next ID, which is some static thing, completely horrible. Right. Should we right. So now the hprintf buffer is in slot 3, I think, something like that, and we poke the descriptor set in. So now it should be ready in the shader, right? So we should be able to use it in the shader, but the problem is, so the GP writes to it. Yeah, but the problem is we need 2 of them. Oh. That's the same problem for the upload buffer as well, isn't it? We actually need 2 of them. We need to double buffer them, because one frame the GPU will be reading from it or writing to it or whatever, and the CPU will be doing the opposite one of that. So you'll get like a race condition, isn't it? So that's actually a bit problematic. So what we need is to actually like do upload buffer 0 and upload buffer 1, right? And then readback buffer 0, 1, hprintf 0 and 1, right? So when we create those the upload buffer, you've actually got in the back end, you've got active frame count of those, yeah? Hey Ray March, how you doing? hprintf buffer, you've as well got 2 of those. Buffers, plural. So now we can save it all. Can jot through the errors. So we actually need to create 2 of those. Really wish to do a 4 range over the active frame. What? Yeah. Just need the 1 because they create with the same stuff. Binding info. _0 plus index. And the memory that you allocate with, maybe we can do 2. If you're flushing memory ranges, let's just do 2. You know what, why don't I just do it twice? Why don't I do 1 big for loop? What's the problem? You know? Just do that, you know? Much better. So these device memories as well. It would be better if it was one allocation, but there's only a few, you know, there's only a handful of these. Device memories, great name. Yeah. Do. Memories, index. Underscore 0 plus index. Man. Oh, that's the mapped one. Yeah, forgot that as well. Mapped memories, GPU active frames. Oh yeah. All right. So we need to repeat that for the hprint f buffer as well. So, you know, we're just gonna copy and paste it over because it's quicker. It's quicker to do the find and replace for upload than it is doing what we just did. Oh, that's readback. Uh-huh. Hprintf buffer cap. Excellent. Why isn't that? Needs some memories. Sweet. So there's still like. So I think every frame, depending on the frame, you have to get a different one back. So depending on the active frame, so whenever you fetch it, all right, so follow these guys around. Where's the? Okay, maybe not. Right, so where we use that. Yeah, that's it. The upload buffer res. This can be hard coded. I don't need these anymore. Let's get rid of those. So you could allocate those from. Or maybe it's best to keep these here, but maybe we'll call these the built-in, right? These are the built-in ones. So we've got like a handful of built-ins, right? We've got the surface, we've got a couple of upload buffers, readback buffers, and the printf buffer. Do I consider myself a fast reader? No. I'm actually like quite bad at reading, but I'm quite decent at reading code, but that's about it. Yeah, I struggle with reading. How about yourself, very much? Are you a good reader? Built-in. GPU surface, right? Mm-hmm. Right, yeah. The struggle is real. It's part of the reason why I hate reading such big paragraphs of text that people write sometimes. Like on the internet, they write like a big blog and it's like, I don't have time to read this. Oh, come on, that frame index has to be out. Of course it does. Just remove that from here. Where does the frame index get incremented? Right then, submit. So right here we'll up it. Ta-da! So many little errors to fix now. So I reckon what we can do is we can set these built-ins, right? So we just say like built-in. So we can go over all the built-ins and just set them up. It's quite easy, it's just a for loop, right? For range, index 0, user start, right? Go over all those built-in IDs, index +1, set them all up. Like that. Should be too hard. So you've got to get this active frame index quite a bit. So it's quite, you know, if I have to do that all the time, it's like I might as well just make it a function, right? So what we should really do, not internal, maybe more I don't know where I'm going to stick this. U32 GPU active frame index void. So this will be super handy. We just want to return GPU frame index modded against GPU active frame count. So that'll basically toggle between 0 and 1 every frame. So we can switch between stuff that we double buffer. So we probably use that a fair bit, or we will be. It's plus, right. There'll be a one for a, can I get the hprintf buffer as well? And there will be a readback one as well. Readback and hprintf, right? So we want those in the header. Cool. Let's fix up some more errors. Ransel says I read. Oh wait, there's still some more stuff I've missed. I had this theory that people who read fast don't mind longer identifiers and end up in languages like C or Java. Okay. Yeah, interesting. Yeah. Well, you know, there's that thing where like sure, it's annoying to type it sometimes, but like reading code is definitely more helpful. It's better to write code that is better to read than it is to actually write. Although that being said, if you're just trying to get something together and get something working, definitely doing the quickest thing is sometimes better. As long as you take a second pass and correct it all. I think I've actually did my literature. Sorry, I think I've actually. Right. Yeah. Like, if you're struggling to read code, you basically need to have, you either like don't know the language too well, or you don't have like your editor or your font or something like this doesn't, you don't have like good syntax highlighting or like know or learned how to sort of like jump to the right places when you're looking through things. Memories, active frame index. This is gonna be really good. Yeah, this is gonna be really good. Right. So we've got the upload buffer corrected there now. That's cool. So have we got this active frame? So where do we use frame index in it? Yeah, all of this, right? We need to just say GPU active frame index, call that. Jobs are good. And why are we using U32 in here? Get out of there. You know? Oh, this is so good. So much cleaner there. Any other time we use frame index, right? What I mean by that is Vulkan frame index, because that's got to be like that instead now. Cool. Any other errors? Right, flushing the memory ranges. This is entirely dependent on the active frame. Upload buffer. Right before we copy the uploaded data. Interesting. Oh yeah, this is another active frame thing, isn't it? Bam. Excellent. 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 Right. So now what we've got to add is the printf stuff. Right? So we've got it, the printf buffer. We've got everything's at the ready. Please still work so I can just, oh no. Oh no, it doesn't work, we broke it. What do we break? Okay. Invalid parameter, we did a null pointer. Wait. A null handle. Oh. Device memories. Not good. We've got to fix that in the hprintf buffer then. Copy paste error. Classic. Right, that'll fix that. Bam. Oh. So we're back to here now. So we've got to do the sync code, right? Now we've got to do the synchronization code. That's not too difficult. So look for upload buffer. Then we've got to do the opposite of flushing, which is invalidate in Vulkan, right? Invalidate caches. So sort that out. It's quite verbose. Oh. Yeah, it's really good for searching, isn't it, Glorious? Yeah. Yeah, very much. We got three compute shaders running, each a layer, right? They're all, yeah, and then like we're uploading a texture as well, so it's cool, it's cool. Yeah, so we need to do this sync code, right? So this is like right before the data gets uploaded, we do this, right? So we don't, like, do we have a readback? Like, how would it work for readback? So for readback, it's like when you submit. Wait, no, you wait for this frame to be free. And then it becomes free. So yeah, I don't know. I've not really sorted out the readback stuff yet, have I? Yeah, I think I might have to think about this. So I think the way it's going to work, right, is in the at the frame start, you wait here for the semaphore until this frame that you're about to overwrite all the stuff for has finished on the GPU, and then when it's finished, you acquire the next image. So I think what we want to do, like we don't have a readback buffer yet, but we're definitely going to add one very soon. And the hprintf stuff is a form of a readback buffer, but it's like a separate one. Yeah, I think the way we're going to do it is we're going to say, right, oh, so at the end of the last frame, we need to put a memory barrier in. At the end of the frame, we need to put a barrier in to say, great, you've done all your work. Transition this into host read, right? And then at the start of this frame, we need to transition it into host. No, not host read, just transition it into compute, right? So the whole idea is, so like this one, we need a buffer barrier. Let's get the buffer barrier. So we'll do right next to the swap chain one. Let's drop it in. Just be the readback buffer. We need like a series of these guys, you know. We can probably just hard code it. So probably just want to say buffer barriers. Right. And then we probably just want to like, so what we're doing is we're transforming the hprintf buffer back to frame. Then we're going from, hey, this was used in a compute shader and it was being written to, right, by a compute shader. And then now we're saying, right, this is being used in a copy and it's a host read. Have we done a host write yet? Oh man, I hate these things so bad. Huh. So is my sync code wrong? Upload buffer. Hmm. Like, yeah, we need to do something where it's like, hey, at the start of... Like... Hmm. At the end of the frame, we need to transition them into host right. And then it needs to come from host right. Right, so it needs to come from host bit. Host. Right, so that's what it's coming from. Yes. Then this is the hprintf buffer. It's going to host. Wait, it's coming from host right. I got it the wrong way around, didn't I? No. This is at the start of the frame right now. So at the start of the frame, it's coming from host right. To compute shader, and we're going to write to it. Then, yep. So let's put that buffer barrier in. Buffer barriers. Core. Cool, then I think at the end we need to do the same sort of thing, right? But we go the other way around. And like we need to do that for... Really the upload should go in with it. Yeah. So what we need to do is we need to take this to the bottom at submit. So at the end of the... At the end here when we do these... perfect. Right. Alright. So what we need to do here is say, okay, this one was being written to... Oh, did we do it wrong? Shoot. This one was being to the top. Host read. So it's being read from by the host. This printf one, yep, that's good. Right, so at the end of the frame, we need to transition this one into host read from storage write in the compute shader. That's it, right? And we need to copy it and do the same thing for the upload buffer. So the upload buffer needs to be transitioned from a compute shader read, right, to a copy write. Excellent. That'll do it. No. Right, so we're online. Doesn't like it. Interesting. Host read not supported by stage mask. Copy. Oops. Let's say host. Don't mind me. Right before the data is uploaded. Yep, that's good. Alright, I'm glad the validation error caught that one. And there we go. So that's now even more correct. And we've added support for the hprintf buffer. So now, whenever we write to the printf buffer, we should be able to read it back correctly. So if we bind... Yeah, so we can simply put it in our shader. And we can like go and steal... So I think you can do... Yes, I think if we simply just set this, we can do a simple print. We throw it to that buffer there, and let's just say like test color, right? Test color equal F. See, F is... I haven't got the... I haven't got the special, you know, .fs yet. I've still got to support those. And if we say splat 4 color. Okay. We could just say logo coordinate, and it would look less like gibberish, but there we go. So now we go to GFXC. So we just need to now set the hprintf buffer, get the resource index, and then do a something like that. Okay. Oh, we got seg4 and HCC. No. It's better wrenching my gears. Let's try the byte buffer. Right, we're getting some crash. Something to do with the... That sucks. I was hoping I could have got the printf stuff done, but yeah, I think we've got a crash in the driver. No, sorry, in the compiler. Oh well. Right. It's getting quite late here. I'm gonna bust a move, but quite good progress today. Got the upload buffers in. We nearly got some sort of readback buffer coming in. So yeah, good progress overall, I reckon. Just got to fix a bug in the compiler now. So yeah, let's find somebody to raid. I will be streaming on Sunday. I know I said last stream my Sunday is going to be cancelled, but things have actually changed around, so I'll be able to stream on the Sunday. Good night, that's right. Good to see you. There is a Discord there if you guys want to come and hang out off stream. Let's find someone to raid. Oh, Kanji, last time he was just doing... I don't understand, he's like programming, but he's just got his camera here, and it's like, what do you... Why? why would you burn internet and just stream and not provide any useful image? It's weird. Who are we going to raid? Thank you, Glorious Sir. Appreciate it. Yeah, it was good to stream. It was good to stream. Always enjoy doing some work. Let's raid this guy, as always. He's writing his own Raycaster engine. Okay. Right, have a good rest of your work week, everyone. I'll see you all on Sunday. Right, bye-bye. Thank you.